guys, today we are going to be simplifying square roots. So that's the title for this lesson. Okay, if you've been keeping up to date on the math that I've kind of given you over the past month or so, then this term should be familiar with you, a square root. So square root uses this radical symbol. This is called a radical. It's also known as a root though. And you can have square roots, cube roots, fifth roots, all sorts of roots. But square roots typically don't have a number here. If they do, then it's like a 2. Okay, so if there's no number there, then we know it's an imaginary 2, which means it's a square root. So if you were given the square root of 100, you'd be saying, oh, that's just 10. Reason why it's 10 is because 10 squared is 100. 10 to the second power is 100. Okay, another common one you might see is like square root of 49. Square root of 49 ends up being 7, and that's because 7 squared, 7 times 7, is 49. But today we're not dealing with these just easy peasy square roots. We're looking at numbers such as square root of 90. Now, is there a number, a whole number, where you take it and you square it and it ends up being 90? The answer is no. And if you have a calculator, whether it's your phone or an actual calculator, go ahead and turn it on. If you were to take the square root of 90, you would end up with a crazy decimal answer, okay? So this says that, square root of 90 is 9.486832981. Whole bunch of decimals. But that's actually not true. These are not equal to each other, and let me prove it to you. If I take this and I square it, we should end up with exactly 90. Let's see if we do. 9.48683291. If I square that, I should end up with exactly 90. And even though it's super dang close, this is not exactly 90. Okay, so I cannot put that square root of 90 equals that. This is where we put the little approximation squigglies, okay? So it's approximately 9 point something. But we in math and in science, we don't like this approximate thing. We would rather have an exact number. Certain times it's okay to have an approximate, other times we want the exact number. So if you're taking the square root of a non-perfect square, because you might want to make yourself a little note, these two numbers over here, 149, those are perfect square numbers. Okay, and if you don't know what I'm talking about, we will be making a list of perfect square numbers. Also, we've done them in 5 videos or something. Okay, but taking the square root of a perfect square number is easy peasy. You end up with a whole number. But this is not a perfect square, so we're going to make ourselves a little note here. We're going to say if the radicand, and radicand is this number underneath the radical, if the radicand is not a perfect square number, we must simplify it. Okay, so we're simplifying down as much as possible. So we are going to write some steps on how to do that. The steps might not make sense when we first write them, but as we practice a couple, you'll catch on. Okay, so let's write some steps. Step 1. Find the largest perfect square number that the radicand can divide by. Find the largest perfect square number that the radicand can divide by. Well, let's maybe write down some perfect square numbers. I'm just going to use the margin of my notes right here. Well, you can see that. Okay, perfect square numbers. Now, there are a million bajillion perfect square numbers. We're just going to list maybe the first 12 or 16 or something like that. The first perfect square number is 1, and that's because 1 squared is 1. 1 times 1 is 1. And then we go to 4, and that's because 2 times 2 is 4. 9, because 3 times 3 is 9. Next up you have 16, 25, 36, 49. So that's 7 times 7. 8 times 8, 64. 81, 100. 11 times 11 is 121. 12 times 12 is 144. 13 squared is 169. 14 squared, I kind of forgot. 196. 15 squared is 225. Yep, 225. And then 16 squared is 256. Now, we could keep going, but that is a pretty decent sized list right there. You're going to refer back to these numbers quite a bit, okay? Now, we like perfect square numbers because we can easily take the square root of them. So I can easily take the square root of 64. Square root of 64 is 8, and that's because 8 times 8 is 64. I can easily take the square root of 169. That's 13, okay? So we like these numbers. So that's step 1, is find the largest perfect square that the radicand can divide by. Radicand is this number underneath. And then step 2 is we're going to break down, and I'm going to write slash rewrite. So you can think of it as breaking it down or rewriting. But we're going to break down or rewrite the radicand using that number. Okay, so using the largest perfect square, we're going to break down the radicand. That's step 2. Step 3. I don't have it in my notes, but it's a good thing to have, at least on these notes. I'd like you at this point to double check each radicand. I'll tell you what that means. Okay, we'll go over that. Double check each radicand. And then lastly, you would simplify the square roots of perfect squares. Simplify square roots of perfect square numbers and leave the rest under the radical. Okay, so those are your steps. Now, another thing that we should probably have in your notes, because this is algebra, is let's talk about if you had the square root of a product. A product means multiplication. So you had A times B. We write that as AB. That is the same thing as taking the square root of A by itself and timesing it by the square root of B by itself. So this is just something to put in your notes, and then we'll refer back to it. Okay, but now we're going to do some examples here. So here is your first example. We're gonna actually take this square root of 90. Let's figure out what the square root of 90 actually equals. So I'm looking at my list of perfect square numbers over here, and I want to find the largest perfect square that 90 can divide by. Well, automatically all of the numbers larger than 90, so like these, those are now done, because there's no way I can do 90 divided by something greater than it. It's not going to equal a whole number. And we're trying to divide and get a whole number. So if you're not great at multiplication skills, then get a calculator. You take 90, and let's start with our first victim, 81. 90 divided by 81. We're hoping it's a whole number, and it's not. So I go to my next one, 64. 90 divided by 64, not a whole number. 90 divided by 49, not a whole number. 90 divided by 36, not a whole number. And we keep doing this until we get to one that actually divides into a whole number. And that's going to be 9. 9 divides into 90 really nicely. So I'm going to now break down the radicand. Radicand's 90, using that number. 9 was our magical number. Well, 90 is the same as 9 times 10. Okay? Now, this is a property of radicals right here. The square root of AB is the same as the square root of A times the square root of B, meaning the square root of 9 times 10 is the same thing as the square root of 9 times the square root of 10. Okay, so we're just breaking it down or rewriting it. Now I need to double check each radicand. Well, square root of 9 is just 3. It's a perfect square number. But I need to double check that square root of 10 can't also break down further. So square root of 10, well, anything higher than 16 is too much. 10 divided by 9, not a whole number. 10 divided by 4, not a whole number. 10 divided by 1, yeah, it's a whole number, but it just is 10, so it doesn't really do anything. So that is just gonna be what it is, square root of 10. I can't break that down further. Now my final answer here, 3 times square root of 10, you can also just write it like this, and this is how you're gonna see it. 3 root 10. And that's your final answer. Okay, let's try another one. Here's number 2. Let's do square root of 84. Square root of 84, okay. Well, I know it's definitely we're not gonna be able to divide by 100 and above. So I could get my calculator and I could start doing, 84 divided by 81, not a whole number. 84 divided by 64, not a whole number. Now, if you're pretty good at your multiplication skills, then this number 4 might jump out to you right away, and I hope it does. 4 definitely goes into 84, so let's just double check it. 84 divided by 4 is 21. So I'm gonna rewrite square root of 84 as the square root of 4 times 21. Okay, so I'm gonna break that apart. Square root of 4 times square root of 21. Square root of 4, that's a perfect square number. Square root of 4 is just 2. Now 21, we need to double check it. Let's double check. Can we take 21 and divide by 16 nicely? No. 21 divided by 9, not a pretty number. 21 divided by 4, not a pretty number. 21 divided by 9 by 1 doesn't really do anything cool. So that is just going to stay square root of 21. So your final answer is 2 root 21. Okay, let's fit one more in here. Let's do square root of 26. Square root of 26. Okay, so if you want to use this little method here, anything 36 and above is too high. 26 divided by 25, not a pretty number. 26 divided by 16, decimal. 26 divided by 9, decimal. 26 divided by 4, decimal. The only perfect square that divides into 26 is 1. And what that means is you cannot simplify this any further. It's already simplified. So final answer is square root of 26. Okay, now I'm hoping you're saying, is this it? Does it get harder than this? Well, I'm hoping this is a fairly easy concept. You're just breaking down non-perfect squares, okay? But there are maybe some trickier things or just some other ways of thinking about it. So let's go over number 4. Square root of 80. Now we're actually going to solve this 2 different ways, and that's because, I mean, first of all, there's like a million different ways that people like to break down square roots. I'm just showing you kind of my preferred method. How I tell you to do it is I tell you, like in our steps, I tell you to divide by the largest perfect square number. But you don't have to always divide by the largest perfect square, which is why we're going to do it another way here. Over here, we're just going to divide by any perfect square number. Okay, so maybe it's not the largest perfect square, maybe it's a smaller one. And what's going to happen is we're going to end up with the same result, just the steps are a little bit different. So 80. If I were to take my calculator and start working my way through this list, I would actually notice that 80 divided by 16 works. So 16 times 5 is 80. So 16 is your largest perfect square. So I can rewrite this as the square root of 16 times the square root of 5. Square root of 16 is 4. And then square root of 5, we just double check real quick. 4 doesn't divide nicely, 1 doesn't matter. So that's our final answer, is 4 root 5. Okay? That's by dividing by the largest perfect square. You kind of get to your answer quicker, in my opinion. Okay? But maybe you're not super great at your multiplication skills, or you don't have a calculator, but you're like, hey, I know that 4 goes into 80, right? Because 4 goes into 8, so it definitely goes into 80. 4 times 20 is 80. Okay, so we could break it apart like this. Square root of 4, that's a perfect square number. But then you're going to have to be careful right here. You're going to have to check this number 20 very carefully. 20. Can 20 break down? Can 20 divide by any of these perfect squares? And the answer is yes. 20 is divisible by 4. So we would not need to break 20 down into 4 and 5. So square root of 4, square root of 5. Okay, so we drop down this 2. Square root of 4 is 2. Square root of 5, I can't simplify that further. 2 times 2 is 4. Bring down the root 5, and my final answer is 4 root 5. Now, I'm hoping you notice you get the same answer either way. Get the same answer. All right, so if you want to take the time and find the largest perfect square, that means that there's no simplifying of the radicand, this radicand that you have to do. But if you know immediately and you're like 4 goes in there, then break it down. You just got to double check this area. Okay, let's do a few more. Number 5, okay, so we got square root of 72, but guess what? There's a negative out front. Don't let that throw you off. You're just going to keep bringing down that negative until the final answer. So 72, 72, if you were to work through your list and start your little dividing, you would notice that 36 goes into 72. I'll prove it to you. 72 divided by 36 is 2. So we're going to rewrite square root of 72 as the square root of 36 times the square root of 2. Drop down the negative. Square root of 36 is 6. Square root of 2 is already simplified. So that's our final answer. Negative 6 times the square root of 2. Okay, number 6. So you're going to have a number outside of a radical here. Now that number, all that it's happening when it's right next to a radical is its multiplication, it's timesing. So this is 2 times the square root of 550. Okay, now this is one where there might be like a big square, perfect square that fits into this nicely. Maybe it's off of our list, but I definitely know that 25 is gonna go into a number that ends in 50. So I'm just gonna start with that. I know 25 is going to go in there. I don't know how many times, so I'm going to use my calculator or my phone and do 550 divided by 25, and that's 22. So 22 is going to go under this other radical. Okay, so there's an invisible multiplication dot there, so I'm going to bring it down. Square root of 25 is 5, and then square root of 22. The only factors of 22 are 2 times 11, and neither of those are perfect squares, so it's already simplified. So we multiply these guys. 2 times 5 is 10. I leave the square root of 22, and my final answer is 10 root 22. Okay, on these last two problems, after you write them down, I want you to pause the video, try them without me. You can totally fast forward to the final answer, or you can listen to me talk through it. So here's number 7. You have negative 8 times the square root of 54. And number 8, you're going to have 3 times the square root of 4,000. So pause the video here, try them out, and then check. Okay, number 7. 54. The largest perfect square that fits in here is 9. 9 times 6 is 54. So square root of 9 is 3. Square root of 6 can't be broken down any further, so we just leave it. Negative 8 times 3 is negative 24. So my final answer is negative 24 root 6. Number 8, drop down that 3. Now, there might be a larger perfect square that's not on this list that fits into it, but like right away, I know 4 goes into 4,000, so I'm just gonna start there. Now, 4 times 1,000 is 4,000. Okay, square root of 4 is 2. 1,000 can definitely be broken down. I know that 100 fits into 1,000. 100 times 10 is 1,000. Okay, so square root of 100 is 10, and then the square root of 10, I can't break that down further because 9 doesn't divide into 10 nicely, 4 doesn't go into 10 nicely, and 1 doesn't matter. So now I just multiply the stuff out here. 3 times 2 is 6, 6 times 10 is 60, and then I leave the square root of 10, so my final answer is 60 root 10. Okay, so that is simplifying square roots. Thank you for watching. See you guys.